I'd like to welcome everybody to our task force for hybridization. We will have some presentations that will give an overview of what we have presented in our position paper, and it will also give you a taste of some of the projects that are happening in Europe. Some of them are sponsored by the European Commission, but some of them are also national projects like German projects and also a French project. So this will give a real feel for what is happening in the digitization area. So really, we're looking at the necessary research and policy to enable hybrid energy storage solutions with batteries, of course, because we are from Batteries Europe. We take the angle that we need to use batteries in hybridization, but it is truly hybridization we're looking at. And we're looking at relevant applications. So we're not imagining an application will be relevant. We look at the case and make sure there is a business case or explain perhaps that there will be. We foresee it in the future, but it's not currently there. So this is what we've been working on. If you'd like to go to the next slide, please. So just to give you an overview of how this will run, firstly, we have this basic introduction. I'm welcoming you here, but I would like to also do a Slido. So I want to get a feel for where you are coming from. If you're coming from the research sector, if you're coming from policies, from governmental organizations, or what position in this, or directly from the industry who are working on this. So we have two questions. There will be a Slido in the next link in the next slide. So one question is which area you're coming from, and the other is about what's your particular interest in this area. So are you interested in the different types of storage? So this is, or the different applications for the hybridization. Then we're going to have a quick overview of the position paper, and it will be very short because we've just 10 minutes and this is difficult to compress into this. But Prasanth will give an overview of the position paper. And he will also talk about the case for grid storage of the grid booster. And he will also describe a little bit on neighborhood batteries. So that's quite an interesting topic. Then we will have Peter, who will come with something on momentary reserve. Then we have a project that's run in Germany. It's on residential stationary storage that will be provided by Christian. Afterwards, then Laurent will take up the vehicle to grid and explain a little why we have taken this particular area, because it's not necessarily hybridization, but it could be. So, but we felt this is an area that needs to be paid attention to. And then hybridization is not only for stationary storage, it is also for many of the mobile applications. So Pilar will give a description of how it is used in a project called Nemoship, which is looking at the maritime sector. And there's many applications in that area. And then we have a few questions or a kind of idea session at the end where you'll kind of let us know what you think is going to be the most impactful thing to do research on. So you can start thinking about that already. You can kind of be reflecting on it through this session. And then we will wrap up the session with Peter. So if you'd like to go to the next slide, please. So here is the Slido link. So when you go into this link, you can go in either on your telephone or on your computer. I'm guessing many of you will use your telephone, and you will find the questions and answers on the link when you go into it. So basically you just take your phone, you put it on the photograph mode, camera, take a picture, then you will see a link. I'm sure many of you know how to do this, but then you will find the questions on the link. So I don't see them just yet, but I'm sure they will be up in a moment. So this is really to, as I mentioned, to try and understand which sector you are coming from so that we get a feel for this. So you see the first question is, what kind of organization are you affiliated to? So if you'd like to tick on that, you can let us know. So the reason we do this, firstly, it's good for our statistics to know which organization you're coming from, but it also gives us a feel a little bit of where we're kind of what aspect we're working from. So we see that, okay, 36 and 27 from like the university and the research sector. So mainly it's research, but we have about 20% from industry, 17%. Then we have some people from associations. Yeah. And yeah, that gives a good picture. And some people from other. So that'll be interesting to understand what other is here. If you're from different, if you just have an interest in this particular area, that's interesting. So thank you for that. That's very helpful. And then we have the next question. Will come up in a moment. So this is, which area are you actively working in? So you're working on grid? Are you working in this domestic? So this is talking about domestic storage. And so one is like in front of the meter, one's behind the meter, basically. And mobility, the transport sector, of course, there's a lot of different fields of mobility where this is applicable. Industrial applications, yeah.
And several choices are possible here. Yeah.
Yeah.
Yes, you can choose several. So if you're particularly if you're from a research entity, you may be working on several sectors. So, for example, and it's interesting to see there are some people working on energy policy, but not so many. But that's also interesting. Industrial applications seems to be quite high, and the grid. So how we're going to implement this on the grid, and of course, mobility has some people in there. Yeah, this is very interesting. So that kind of gives us a feel. We're quite an academic audience, really. That we have about 20% from the industry, which we have to really make sure that we're talking to you guys also. And we have some people who are working in the policy end of it, which will also be interesting and be impactful in the long run of what is going to happen here. It's 12 minutes past. I see I've talked for a little bit too long, so I'm going to we will go to the next slide now. You can find the position paper. There's a link for it on the next slide. And you can go to the Batteries Europe website, basically, and you can find it there. But first, I'm going to allow Prasanth to take the floor and to present the overall position paper and to give you a feel about the kind of grid booster and also the neighborhood battery, which I see he's snuck into that presentation. So thank you. Prasanth.
Thank you, Edel. Without wasting time, I think I will get on to the case today. So it's why develop a position paper on hybridization and also the case for the grid booster. So my name is Prasanth Venugopal. I'm an assistant professor at the University of Twente in the group of Power Electronics and EMC. So first of all, let's look at the question of what is hybridization. There's quite some misadventure when it comes to defining hybridization properly. It's also why we spend quite some time trying to figure out what hybridization means. So ideally, when you have two or more energy sources which are combined to give a particular benefit to a chosen application, that is hybridization. But then obviously there are different types of hybrid systems as well. Heterogeneous battery systems, you may combine, for example, a high power cell with a low power cell, or you may combine different chemistries of lithium-ion batteries within an application, etc. Then I think heterogeneous battery systems are the nomenclature, for example. Now, you may also think of hybridization at a micro level. For example, if you're in an aerospace application in the future, you may be SAF propelled, with sustainable aviation fuel, but you may still need electrical systems for gears and also, for landing systems, for air conditioning, etc., which then relies on a battery, and then that kind of hybridization is then a micro hybridization, for example. There are also other hybridizations which our position paper describes. For example, internal hybridization, which could be a cross between a battery and a supercapacitor, or which could be a cross between an electrolyzer and a battery, like a batterylyzer, for example. So we have defined all this in our position paper. Next slide, please. Yeah, so of course, why should we hybridize systems? There should be benefits. So obviously, as you can imagine, the benefits are cost, performance, flexibility of the system, extended lifetime. If one particular, let's say, a battery system alone is not able to take care of both, the peak shaving or the dynamic demands of the battery, as well as, the let's say, the constant sort of demand, then having a hybrid system must give the benefit that it must improve lifetime, or it must improve reliability, sustainability, particularly with second life batteries. In fact, when you can use them, give them a second life by repackaging. And of course, hybridization systems also find case in energy security, for example, in uninterruptible power supplies. So we are not hybridizing just for the sake of it, but then we are looking at really what are the real key benefits in specific areas where it makes absolute sense to do so. Next slide, please. So of course, what are the objectives of the position paper? It is to identify the research needs for such kind of hybrid energy storage systems. We're also looking at policy, because that is extremely important, especially when different technologies are coming together. And also we identified some relevant key business cases there. Yeah. Next slide, please. So when we looked at different overarching cases for hybridization systems, we came up with three common research sort of needs, which are then clustered as efficient and flexible power electronics. That's extremely key. We also look at communication sensing, and from battery management system all the way to energy management systems. And importantly, we also think of knowledge sharing, the community aspects, business case analysis, and of course, policy, which is a very important sector as well. Yeah. Next slide, please. So when you're looking at efficient and flexible power electronics, specifically for multiple technologies of energy storage that are coming together, you may want to look at things like multi-level power converters, multi-port power converters, also fault-tolerant power converters, converters which can operate efficiently over a vast voltage range, and which can deliver the peak power capacity, but also be safe, that it respects the safety margins, etc. And we also think of power control here, especially when you have multiple hybridized systems. So this is the pillar then of efficient and flexible power electronics. Next slide, please. So in the next pillar, where we think of communication sensing, we need to make accurate estimations of states of the battery, the state of charge, the state of health, etc. So we need to be able to have these safe operating windows within which the batteries can be operated and to be able to maintain that kind of a safety operation, we need to have good sensors which can enable SOC, SOH estimations, etc. Here we are also thinking that new digital tools which will replace classical tools come in. Also in the task force sort of digitalization, it was much effort was also given to machine learning and artificial intelligence based techniques, which are coming up in a big way, especially here. Now we need to also look at what is the remaining useful lifetime. So forecasting of battery health, battery life, etc. Again, there communication sensing is extremely key. We're also looking at novel control for hybrid energy storage systems, looking at optimal layout and dimensioning, etc. So these are key research aspects when it comes to communication sensing and battery management systems to energy management system. Next slide, please. Yeah. And of course, the community aspect. So we need to have knowledge sharing, whether it be researchers, use cases, and also other stakeholders, including industry, decision makers, policy developers, etc. We need to provide proper guidelines based on the community. And we also need to think of development of software that is going to make or optimize projects, looking also, among other things, in the economics and also for sustainable business case, because that is important. So in our position paper, we also highlight key business cases where in sectors where it really does make sense, right? Next slide, please. So we have actually four broad pillars or areas into which we have classified our applications. So for hybrid energy storage systems, there's behind the meter applications, so stationary storage. There's also grid, including vehicle to grid, so the in front of the meter applications. And among mobility, we're also looking at shipping as a sector and aviation as a sector. So these are aspects that's covered in our position paper. Next slide, please. I'll give you a couple of snippets of key cases that then give you an example. So for example, grid booster. So you can imagine that, for long-term energy storage systems, you may want to hybridize between, for example, a redox flow battery with a high-power lithium-ion battery. So this combination is useful because, you can do both, let's say, constant sort of load applications, but you can also deal with the dynamics where the battery can take over in that case. So here, you may even be able to extend the lifetime by hybridizing these two systems, and also key benefits, including cost, rapid response capability, high capacity, and longer utilization of the grid booster is possible by hybridizing systems. And we can, of course, enable seasonal storage. But then the research needs here are, we need to be able to understand how the grid integration happens. We need to understand or demonstrate these systems. Flow batteries are a different technology compared to lithium-ion batteries. We also must look at digital twinning, which is an important aspect when it comes to trying to understand, let's say, the physics behind some of these technologies as well. And we also need to develop business cases and policy, both nationally, but also across European borders. Next slide, please. And next comes the key case of a neighborhood hybrid battery. So if you are in a neighborhood, you may want to imagine a storage system that can actually cover, for example, a village, or cover a small town, for example. And here again, you can think of activities such as redox flow battery with lithium-ion batteries, or there could be cases where you have a lot of electric vehicles in a community, and all of them together can actually power the grid, for example, using vehicle to grid technology. So in that case, lithium-ion batteries, maybe of varied chemistries from different car makers, might come in. So here again, we need to make accurate estimations with our BMS when it comes to state of charge, state of health, etc. And for number of electric vehicles which are provisioning vehicle to grid, we need that infrastructure. We need the interconnected mobile EV batteries together as well. We need to understand energy management better, and we need to be able to manage this complex system, both of them together. Of course, peak shaving can be taken over by high power technologies, and energy storage can then be given to the part which has the high energy capability because of this benefit of cross hybridization. And this would mean that there's better utilization ratio for the whole, let's say, technology as such. Next slide, please. Policy implications. So I think we all agree that especially when different technologies come together, policy is an important aspect, and it's really a critical building block, especially when it comes to the current era of climate change. So we do need clearer legal definitions, so that we can harmonize and better develop the field. The regulatory framework, especially for hybrid systems, we think could be better harmonized. And business case, there's policy-driven opportunities which I think we need to explore more, and therefore the push can come from the policy sector as well. Okay, thank you. Next slide. So the main takeaways, our position papers has actually identified key application areas where we think hybridization makes sense and where it's needed. We have identified different advantages and sound business cases wherever it makes sense. Identified the research needs of each sector, and we also have considered policy, because that's an important aspect which we think must be handled not just at the regional level but also across Europe, because this is very, very important, especially for hybrid systems. Next slide. Yeah, I think with that, my short presentation has come to an end. I hope I've kept the time.
You have
yes,
very much. You have
Yes.
very much kept to the time. I have to say, well done, because this is not an easy thing to present. I hope that everyone has understood what we've tried to do in the position paper. I think this also, perhaps we can make some comment about the digitalization workshop, because we've just had this workshop on digitalization, and it kind of connects nicely to what we're doing in a lot of cases. Have you any kind of comment on that, on how the different places it connects?
Is the question to me?
Yeah, perhaps
Yeah.
you can take a comment on how you see the connection between the digitalization workshop and the workshop we're having here.
Yeah, indeed. As we said, like, the communication, the sensing aspects are very important, especially if you're looking at a long lifetime of a hybrid system. Because, if hybridization has a target that you want to extend the lifetime, then you need to be able to be aware of like what are the states of SOX, capacity, state of charge, state of, let's say, health of the battery, etc. So digitalization technologies are extremely important, especially in trying to link between, the current battery management system to the energy management system as a whole as well. So I do see that playing a role. In fact, grid-based applications would certainly need a lot more digitalization than we have now. I also think even neighborhood batteries will benefit a lot from this kind of digitalization techniques coming in. Yeah, that's my perspective.
And Peter, you made a small comment later, and I'm just going to about the ontologies and how that can impact, because here we have an issue of even defining what we're doing. Could you make a comment on that before you start your presentation?
Correct. Yeah, I can do a comment. I see this very important, this work on ontologies, because this is the basic work to digitalize or create the language for digitalization, let's say. And of course, there are ontologies for different levels. I really advertise to connect these all, and also connect it to a connection to the sustainability group, because with battery passport and so on, there is already a need for digitalization. I think this can also help if we can also include this method to the battery passport, for example, or link it. I think these three topics, digitalization, sustainability, as well as hybridization, are really intertwined and interlinked.
Yeah, I think we will show this more and more as we go through this. Of course, there are physical components that must be addressed, but there are clearly a lot of progress can be made in the digitalization side to advance this area. And this is really, we need to very much work together and to make this a reality. So we're a little bit ahead of time, 3 minutes. I have to say thank you very much, Prasanth. You've given a brilliant overview. Perhaps you would like to start, Peter, because I've given you a moment for momentary reserve.
Yes, okay. Thank you very much, Edel. So I will present a project which has been funded by the LCBAT call in the Horizon Europe program, which is called HyFlow. And I will only demonstrate, because it's a really large project on hybridization. It's on this, it was one part of the first hybridization call. I will only show a small section where our institute was active, and this was for building a virtual inertia on a larger scale. So maybe next slide. So what is the problem? If we look at energy markets, and there you can have a look at the lower picture, I think especially when we look at the grid, a lot of the time domains are really enshrined into markets. Like we have the primary and secondary reserves, we have hourly reserves, and then we have, of course, the energy market. But we have two markets which are not addressed in the future properly. And this is, of course, what do we do if we have more penetration of renewables? Because these problems, which this integration of renewable makes, was not a question in the past, but could be a question in the future. So we have the ultra long duration storage. This comes really to seasonal storage, where we don't have any idea how this will be financed, or if we have a market. And there is this ultra short duration, which at the moment comes for free due to spinning turbines. And if we replace the turbines by power electronic driven solar fields or wind turbines, we will have the problem that they are switching on another time scale. So usually in milliseconds, but we don't have any control in the sub-millisecond area, which these spinning turbines were giving. So this will not maybe be a problem at the first in Europe's Central Europe, because we are very well interconnected and will have still nuclear power in our grid, but it will already be a problem in islands, also larger islands like Ireland, where we all have a lot of wind turbines, and this can become a big problem. But we don't have a market, we don't have any idea how we will do it in the future, who will pay for it, because at the moment it comes for free. So next slide, please. So the objective of HyFlow was to build a demonstrator on the larger scale of a virtual inertia, so to develop the grid forming control method for the grid side converter, to an experimental evaluation of grid forming control methods, and then the upgrade to a larger scale hybrid energy storage with virtual inertia. And the project partners were the KIT, our institute, Fraunhofer ICT, and a company, Frequon, and this was all accompanied by Energy Institute Linz, who made the LCA and life cycle assessment and life cycle costing. So next slide, please. So yeah, where is it integrated? So we integrated the virtual inertia into our maybe quite unique energy system, which we have on our ground. So we have a 2 megawatt wind turbine on our ground, and also connected on a DC level around 650 kilowatt peak solar panels. And and we also have a vanadium redox flow battery. So one module is also connected on a DC link to the wind turbine in DC intermittent circuit. And in this project, we used this infrastructure, implemented a supercap, a 900 kilowatt, 1.1 kilowatt hour supercap, and also included or modified our inverter so that it's had the fast switching capabilities to provide the virtual inertia. So the idea of this hybrid storage is to make a virtual power plant which can deliver on all time frames with the help of renewables. So next slide, please. So the first part was, of course, of KIT, who first started to make research what kind of fast control mechanisms there are, and they decided to favor the self-synchronizing synchronverter, which is a special type of inverter technology. And they first started with a time-discrete simulation and MATLAB Simulink to really model the response for frequency and active power. So next slide. The next slide, of course, to rebuild it in the laboratory, to test it. So there was a kind of test rig developed, which takes power out of the KIT grid and then converts it to a DC intermittent circuit, where then the synchronverter was tested and then fed in back to the grid. So this test bed gives the possibility to test all the control strategies, especially that we don't overshoot here, and for especially the current control is here very important. And they could show that one control cycle with this synchronverter was 50 microseconds, which is fast enough to do virtual inertia. Next slide, please. So the next step was that this all was integrated. So we have this supercap bank, which has been developed by the company Frequon. It was integrated to the energy system at the Fraunhofer ICT, and we implemented all the grid forming strategies inside and tested the system. And yeah, this was one idea of, or I think, maybe not today a relevant application, but we see a future application. Of course, you can do a grid, a momentary reserve also with a short storage alone, but I think it will be really interesting when you combine it also with renewable energies and long duration storage, because then you can provide all the capabilities what a power plant also can. And I think this is my final slide, or maybe next slide. Yeah, I'm at the end. Thank you very much.
Thank you very much for that, Peter. I think this is quite exciting to see something that you take from concept and you demonstrate. Of course, it's not connected to the RES system, so the renewable energy system, but I expect in the future, you've created a solution that will be needed. The question is, how will policy address this really?
Yeah, so this is a good question, because we don't have a market at the moment for momentary reserve, but we know we will need one in the future. At the moment, it's not clear if it will be just becoming part of grid costs, or if it will be part to make it just by regulation of large producers of renewables. So because it comes with a cost, so you have to install the infrastructure, you need this super cap to do this. And so we see some benefits of making a combined solution on DC buses. DC buses, of course, has some downside, like we need special infrastructure, like switches are difficult in DC. But on the other hand, DC buses can be stabilized very good with energy storage, and you have a very simple control strategy that you only control for the DC voltage. And this makes it quite interesting. And so this topology of DC buses will play a role in the future, I think. Yeah.
Do you see this, because here you've used redox flow and you've used these supercap system. Do you see any other combination being used for this particular application, for example?
Of course. For the supercaps, we could also use high power lithium, which is definitely cheaper from the capex. And of course, any long duration storage could help. This could be also any other storage. Yeah, so it could be also two types of batteries. Yeah, lithium-ion batteries, like a Titanate system together with as a high power system together with NMC system, or yeah.
And when you're talking long term here, you mean maybe 4 or 5 hours. You do not mean, because there is a bit of a distinction, and this is a little bit about going back to what was discussed in the previous meeting about the ontologies and about having good KPIs. That understanding what long-term storage is quite different depending on the picture we're looking at.
Yeah. Of course, when you are making lithium-ion battery long duration storage, the layout will be quite different than for the typical lithium-ion battery storage, because you have to, let's say, shrink your usable state of charge window, but also possible. Yeah, it's just in the end, it's a question of cost if you take redox flow or lithium-ion batteries.
I see.
And KPIs.
We're running quite well on time, so I would just say if people have some questions, they can ask them in the question and answer section. We will not be able to address everything, I would imagine, but we can take a couple of them and address them to the various speakers. So mention which speaker you would like us to ask the question to, and they can take a look and see if they can answer it. If we can't, we can always come back to you as well. So this is something that we can do in the long run. So our next presentation will be by Christian Kupper. I hope I pronounced your name correctly. Please correct me if it's incorrect. And you're from KIT, and you're working on the Biflow project, which is about residential stationary energy storage. So this is a little bit different. This is the residential, it's the kind of smaller scale, and it maybe connects a little bit up to this neighborhood battery idea, perhaps?
Yeah, kind of. Thanks for the introduction. As we have a quite large student dormitory, it's a little bit between like normal home storage and like a little bit bigger applications like grid storage. Okay, so let's start. So I want to talk about like this Biflow project. So innovative hybrid storage solution for the building sector. That's the way I called it here for the presentation. We can go next. just short overview. I will briefly say who I am, who we are. Then I will present the key data of the project, then present the hybrid ideas. There are like 3 main ideas behind it, like innovative ideas, if you like, following by explaining the energy system. Finally, I will show some data that we already acquired, proving the concept, and I will end with a summary. Okay, next. So who we are, like I'm working at BARTEC, so Battery Technology Center at KIT. So it's 5 different institutes together from material science, mechanical engineering, production science, but also we from Electric Technical Institute. So like really like making research along the whole value chain of the battery. Next. So my working group is going tackling a lot of topics, like when we take the cells and build the modules, so BMS development, thermal modeling, agile packaging, and so on. And the other group from Electric Technical Institute next is system integration. So, and then for the B-Flow project, both working groups, like if you dig next, both working groups work together, as we have parts which are a little bit more on the pack level and parts which is a little bit more like system integration of a whole energy system. So you can go next. Yeah, exactly. So this is the other working group. So, and the project, here's some basic data. So we had the project running for 4 years now. It was funded by our German Ministry for Economic Affairs and Climate Action. We have 2 partners. It's Fraunhofer ICT, who give us an optimized electrolyte so we can take higher temperatures, and then First for Energy Solutions built the flow battery and adjusted it for our heat recovery purposes. And then we had an associated partner, which was the student dormitory. By the way, it's like 150 persons, so it's quite large dormitory already. Okay, next. So I want to go through the main ideas. So like these are the innovative ideas, if you like. So hybrid operation of lithium-ion battery and vanadium flow battery. This is like, we are not the only one doing that, of course. Then we have like really like new ideas, like really using the heat losses of the vanadium flow battery and also using the storage, the vanadium flow battery as heat storage and as electrical storage, both at the same time. And if you want to work on, like, if you want to finish these ideas, or if you want to be successful with these ideas, you really need a fourth innovation, if you like, because it's a really complex energy system where you not only have to decide if you want to charge, for example, the flow battery or the lithium-ion battery, but you also have to decide, do I charge now electrically or thermally? Okay, next. So this is the overview of the energy system. So we have of this student dormitory. Again, it's a real life lab application. So really build it inside, not in a lab. It's really like inside real life. And it's an AC backbone. So we have like local PV power from the building. We have even local wind power from the building, even though it's a little bit small. We have these 2 storage systems. And then we use the waste heat. So this is what we call the thermal coupling system. So we use the waste heat of the flow battery to preheat the tap water of the building, just like to use this waste heat. So this is it already. Okay, next slide. Here, just a little bit more information on the batteries that we used. So we have a vanadium flow battery, which has the higher capacity, and then we have the lithium-ion battery, which is a little bit like the idea is that this is the assistant for the flow battery. So I mean, we are coming from the field of hybridization. For us, like the way I would pronounce it is, so we try to optimize the 2 together, that the vanadium flow battery can operate like always or most of the time at optimal working point, because the flow battery is a little bit more sensible to, the efficiency of the flow battery is more sensitive to the operation point. So for lithium-ion batteries, it's much easier. So it's a little bit like the idea of Toyota Prius, if you like. So you have like in Toyota Prius, you have like hybrid, the old one, you have like the combustion engine always running an optimal point, and then the battery and the electric motor is like doing all the stuff around. So it's a little bit the same here. We try to run the vanadium flow battery relatively constant at optimal point, and then the lithium-ion battery is a little bit taking care of the fluctuations. Okay, next. Okay, so we are already there. I want to show some data, if you like. So proving the concept means I want to show like just for the 3 main innovations, if you like. I want to show some data, at least what you see here in the picture, by the way. This is like the thermal coupling system. So yeah, like pump and heat exchanger and so on. And also you see like on the right part in the building the flow battery, and on the left part in the background the lithium-ion battery. Okay, next. So for the lithium-ion battery and vanadium flow battery as a hybrid storage, so we don't have published yet a paper where we really show like in numbers if we can work out a more efficient system. I mean, in the way, of course, the lithium-ion battery is always more efficient. So we just want to prove that the vanadium flow battery would run more efficient. But even for that, we don't have yet the numbers. I can just show you this example. It's active power over for the building, like for the energy system over 1 day. And you can see like, well, as you can see, like it's grid, load, and the batteries. And if you go next, there's some small zoom, and you can see that like in orange, the lithium-ion battery is taking more care about the fluctuations and also the peak during noon. And then we try to run the flow battery just like even it's not running, or it's running at optimal working point and constantly. So here I can just say, okay, what we still like testing, like this is the strategy, but I don't have yet like nice numbers proving that it's really more efficient. Okay, next. Okay, regarding the heat recovery. So this is one example, at least. I mean, again, like it's not running. We don't have data for an entire year, but here at least for the efficiency, the overall efficiency increase, I have data from just the round trip efficient, like for one round trip that we did. It's with 21 kilowatt. So it's the fastest for the flow battery that we have there. So that's why the efficiency from an electric point of view is quite low. We have 56%. But as you can see, like in red, this is the amount of energy that we could recover in terms of heat that we use to preheat the tap water of the building. So at least we are like, then finally, we go back to like 80% overall efficiency if you look at the whole energy, which is actually, by the way, even if you take other round-trip efficiencies or if you look at other days, normally this is where we arrive normally. Like it's even if the flow battery is more efficient, again, we reach like, we have less heat recovery and we reach again overall efficiency of 80%. Most of the time we are landing around 80%. Okay, next. Yeah, and then before some last thing, so we see like third idea was like dual storage vanadium flow battery. Again, we don't have any publications for that. So the idea is like we have this storage and we can just intentionally heat up the storage with some surplus PV, for example, and we use like the same tank that is using the energy, storing the energy from an electrical point of view. Also, it's saving thermal heat. But for that, we don't have yet the data. But what I can say, at least, so you're running the system for more than 1 year, and we had a lot of high temperatures so far, and it's still, we don't see any significant aging. I mean, Peter can correct me if I'm saying it wrong, but I think we don't have any significant aging yet, even though we had like really high temperatures, like above 40 degrees, like the whole last summer, actually. So like in terms of concept, it seems to work in general. Okay. Thank you for your attention.
Thank you very much for that, Christian. That was it was very enlightening to see something that's also demonstrated on a different scale. It's good to see that dormitories are modernized. From having stayed in one many, many years ago, it's good to see that there is changes and developments, and these buildings are really becoming environmentally friendly, that the entire system. Also, I very much welcome that you brought this concept of, like, generally what we've talked about is electrical hybridization, but you brought in like thermal and electrical, where you're utilizing the excess energy for heating, which is also very interesting and a very important concept. And it could be also, as you say, you've had really high temperatures in Germany over last summer, and this is a really good demonstration of how the energy can be used in the best possible way, that you really are not losing a lot of energy. So thank you for that presentation and kind of maybe opening our eyes a little bit. And also, I realize this is a project that is ongoing. It's very much appreciated that you're willing to, let us have a peek view of what is happening in the project. And that is very good. There is a question for Peter, but I think I will actually take maybe the next presentation and we take the questions a little bit towards the end. So I do see we have some questions, but we will collect them. So I would ask that Laurent, and if you can introduce yourself and introduce the vehicle to grid and explain why we took this concept up, because it's not strictly hybridization, but it could be. But
Yes.
That would be great. Thank you.
Yes, I will try. Thank you, Edel. So my name is Laurent Garnier. I'm working in CA. So as Edel said, vehicle to grid is not exactly an hybrid system as we have defined it in the position paper. But if we look to this topic, and if we see that on the grid, you can have different technology of battery in different vehicle, we can perhaps have like an hybrid system in which we have to manage the energy. So this topic was not covered by other groups. That is why we decided to put it in the position paper. So next slide, please. So I will come back. The agenda is a short presentation of CA. After that, we come back on a few definition of V2X because there are a lot of terminology, and then how it works, V2G, the potential of V2G with the example of France, an example of demonstration in France, and then the research area around V2G. Next slide, please. So as I said, I'm working in CA. So CA is a scientific and technology research player. And I'm in an institute which is called CA LITEN on new energy and nanomaterial. And my department is the department about electricity and hydrogen for transport. We are working about electromobility. I'm a power electronic expert, and I'm leading a project about battery system, fuel cell system, or hybrid system. Next slide, please. So just to come back on few definition, what is vehicle to grid? So we heard about V2X, V2G, V2 Home. I think there are two important words in order to define what is V2G. The first one, you have to know if you have a unidirectional or bidirectional system. And then you have to know if you have a control or uncontrolled system. In the first case, if you have a unidirectional and uncontrolled, there is no terminology behind. It's only a personal optimization of charging. After that, if you have a charger which is unidirectional and controlled, then you are in the case of V1G, and we call it smart charging also. And then if you have bidirectionality in current, but also possibility to control either current or the time, the hour at which you decide to start your charger, then you can have vehicle to home, you can have vehicle to building, you can have vehicle to grid, you can have vehicle to everything. Just if we have a look on the graph on the right side of this slide, you can see the difference of between V2G and V1G. Here you have the typical winter electricity consumption in France in winter. So we have a peak in the evening around 80 gigawatt. If you have V1G, you can shift this peak during the night. If you have V2G, you can also shift this peak, but also you can decrease the peak because you can feed electricity in the grid. Next slide, please. Now, if we try to see how V2G can take place with the current standard, currently we have 4 standards in Europe. Let's perhaps only 3, Mod 2, Mod 3, and Mod 4. The Mod 2 is when you charge your vehicle, you have a communication for safety, but you have no control. So if you have no control, V2G is not possible. Then you have 2 other possibilities, the Mod 3, which is a charging mode in AC, in which you have control and communication, but the peak power is limited to 42 kilowatt. And you have the Mod 4, especially for fast charging. You have also control and communication. So we think that the best candidate for V2G is the Mod 3 because it's important to have high efficiency and also to limit the aging of the battery. And if you have high current, so if you are in Mod 4 with fast charging, you will have losses in the battery. So because you have a lot of exchange between the grid, between the battery, and so on, we think that Mod 4 is not the best candidate. For us, the best candidate is the Mod 3 with low power charging or discharging, because you will have certainly better efficiency and you will have certainly a lower impact on the aging of the battery. There are no major technological challenge on bidirectional charger. They are already existing, especially in Japan, because the standard were adopted earlier. CHAdeMO standard with V2G. Thank you. Next slide. Just if we have a look on a bidirectional charger, we have 2 kinds of bidirectional charger. We have the non-isolated bidirectional charger on the right. For example, BYD has already installed this kind of charger in his vehicle. And on the left, we have isolated bidirectional charger. So this is the 2 kinds of charger we see on the market currently. On CA, we are working especially with Renault on a bidirectional charger with a GaN component inside, with a wide bandgap component. So the objective is to have better efficiency and also to have a smaller charger with lower price. So the bidirectional charger is a little bit more expensive because inside you need to have a semiconductor like a transistor instead of having diode. So it's a little more expensive, but there is no big difference. So for me, the technology is ready, and after it is the problem is something else if V2G is not adopted now. Next slide, please. So just to give a few order of magnitude, so it's not realistic, but just to give order of magnitude. The forecast in France in 2035 is 10 million of electric vehicles. We know that the average utilization of the battery is about 50 kilometers per day. It's almost 15% of the capacity of a standard electric vehicle. Today, the vehicles are parked about 95% of the time. And the last point is very important. The last generation of batteries have a number of cycles which is around 3,000 cycles and perhaps higher with iron phosphate technology. And it was not the case 10 years ago. So this point is very important. It means that the aging is not for me, it's not anymore the big issue for V2G. If we see with 10 million vehicles connected to the grid, with only 3 kilowatt in bidirectional with a bidirectional power, we have a power of 30 gigawatt available. And in comparison with 100 gigawatt, it is a peak consumption of France in winter 2024. So, as I said, it's not realistic, but if you take only 3%, 10% of this amount, it is already 3 gigawatt, and 3 gigawatt, it's a lot of peak power. So this slide is just to say that we have an important potential of flexibility with V2G. Next slide, please. So it's just an example of project, demonstration project we have in France, which was funded by ADEME. ADEME is an organization about the energy transition in France. And in this project, they address intelligent control, integrating EV into the grid, and flexibility management. So I was not in this project, so I can't say you more, but it's just to say that it's a project in which big player was in this project: Renault, Stellantis, Enedis, Schneider, and so on. And this project is always ongoing. The last slide, please, Edel. And here we try to identify the main research area about V2G. So the first area on battery, because we are in BEPA, we have to evaluate the impact of V2G on the battery aging. It is important, even if we think it's not so big. We have also to standardize the communication with a different vehicle for V2G function. For example, we have perhaps a new estimator to have, like state of power estimator, especially for V2G. Concerning charging, we have to improve charger efficiency, especially at low power, because we think that if we have V2G, it will be at low power. We also have to manage the charging and discharging phase of vehicle according to the need of the network, but also to the state and technology of the batteries. For the network integration, we have to evaluate the impact of V2G on network stability. We have to think about optimal energy management, and also we have to think about how to push user to connect a vehicle to the grid. There is certainly a big topic about economic and business model, because there are a lot of stakeholders on the value chain, owner, aggregator, operator, and so on. And certainly we have to think to a business model which redistribute to all the stakeholders. We also have to analyze cost benefit of V2G, and we have to think about policy and incentive. Concerning environmental and societal impact, we have to evaluate global CO2 emission and to study how to ease consumer adoption. And at the end, we also have to think about regulation and standardization, as I said before. Thank you for.
Thank you. Thank you very much, Laurent. I think you've given us a good overview of some of the issues, and also this is far, far ahead of what I had envisaged. In Norway, we have many electric vehicles where I'm living in Norway. So I expect it would be a good test bed because we have such a high adoption of electric vehicles and a lot of people who are very willing to do something that's very forward-looking. So maybe there can be some projects to address this, and I think there are some around Europe that we have to use the learnings from each other. That's very important that we do this now, that we learn from each other. We've seen in this, there are policy issues that need to be sorted out, but I think perhaps the European Commission they've certainly pointed this out as an important area. And they have identified this, and I think Jens will tell us a little bit more about that. So I will ask Jens maybe to talk a little bit about kind of the policy related to both the vehicle to grid, but also a bit about the hybridized energy storage systems. Some things we have to solve by using the science to work on it, but some things we also need to work hand in hand with the policy. So Jens, if you'd like to take it away, thank you very much for joining us today. I'll just briefly say you're a policy officer from DG Ener, and we're very grateful that you have taken the time to join us. So the floor is yours.
Thank you very much, Edel. I hope the audio is acceptable. So good morning to everybody, and really congratulations for this position paper. I've started reading it. I'm not completely through already, but it's a super overview. And it gives also to me, it gives several points for food for thought also for our R&I upcoming program. So that's very interesting. Thanks a lot again. We have now heard some very detailed, great examples. But yeah, as you said, I'm going to dive into a wider overview that obviously can't go that much into detail, but will give lots of connection points to what you have said before. We are obviously all convinced that energy storage is indispensable for the clean energy transition and that it will play a crucial role for flexibility, stability, and reliability of the future system. But we heard from Peter, for instance, there are still some technical barriers that have to be overcome when it comes to inertia, but there are also economic barriers when it comes to lack of financing, notably in the case for long-term duration storage, and there are still double taxations and tariffs, and sometimes the lack of awareness at national level of the role of storage, and this has to be overcome in the future. We tackle this already in many, many ways. I'm just going to pick on the most important that directly jumped to my mind when I was preparing this. So we have recently adopted the electricity market design, and this requires member states to assess the electricity system flexibility at a national level and then give indicative national objectives for non-fossil flexibility. There are the Commission recommendations on energy storage, and they call again the member states to overcome the remaining regulatory barriers and taking storage into consideration already at grid planning stage and then always later operational stage, and ensure that storage can actually participate in the existing market schemes like capacity markets. That is another big issue. These services have to, at a certain moment, have to be sufficiently remunerated. And yeah, we can try, but that's something we have to all work together, and which in the end is a decision of the market, but we hope we can get there. We hope that these new provisions actually provide a very strong push for batteries and other forms of storage, but as well as the hybridization of these different kinds of storage that we have heard about this morning. it has to be underlined that the Commission takes a completely technology neutral approach. So whatever works best will be supported. We're not pushing for certain kinds of storage, but they obviously have to have the benefits that we need for the grid. At the same time, we also recommend member states to continue the support for research and innovation in new technologies. We do this as well through our framework programs for R&I, but it needs private, it needs national and European funding to come to a level that will support it well enough. The EU policy that we bring out already provides basic principles for promoting energy storage, for instance, in the revised Electricity Market Directive, which recognizes the important role of storage. This electricity market design actually introduces, for instance, specific provisions to promote power purchase agreements. But also to make those power purchase agreements more accessible to smaller actors. And with a whopping 16 gigawatt of capacity contracted in only 2023, these power purchase agreements have to become one of the key instruments to finance the deployment of renewable energy capacity. Power purchase agreements are also very flexible instruments, and we expect that they adapt to the integration of storage in renewable installations, as storage will allow the buyer to actually receive more hours of renewable energy input. Then there's the Renewable Energy Directive, which entered into force last November and which needs to be transposed by May 2025. This, if just one number is to be given, then it would be the EU binding renewable energy target of 42.5%. Which we aim to achieve in 2030 with aspiration for more, up to 45. And there's a new indicative target for 5% of innovative renewable energy technologies that have to be achieved as well. In the same time horizon, we expect renewables actually to make up to 70% of the electricity generation, which arguably somewhere there's the 50, 60, 70% line where things really get tricky. So I hope by then we are far enough already with application of our storage to not run into any problems once we reach this. Up to date, the renewables are on an increasing path, and in 2022, this data always lags a little bit behind, we reached 23%, which was a big step from below 20 in 2019, and with the most significant growth in the electricity sector. But despite this nice trend, when we analyze now the national energy and climate plans that we got from the member states that would implement actually big parts of this, we unfortunately have to see that all put together right now would just reach 39 or even less than 39% in 2030. So we are still behind the target. So ambition has to be increased further at the member states level to reach this. And then we talked now also in the last presentation about electro vehicles. And for instance, the Renewable Energy Directive specifically promotes smart and bidirectional charging to enable this big capacity that we have in the EVs to become a flexibility asset in the electricity market. And I'm really happy to hear that you underline as well that now actually lifetime of battery, if handled well, is not really anymore the problem and shouldn't be the deterring agent that we had in the past, that people thought they would destroy their cars by actually engaging into bidirectional. It is estimated, and again, this is a big number and can be discussed, but it's in the ballpark of 3 terawatt hours that would be available in battery capacity in 2030 all over. I mean, especially coming from the electro vehicles, which would be equivalent to around 40% of the union's daily average electricity demand. So it's huge and has to be tapped. And again, you're right, even if it's just 10%, or if you dream that it's higher, but I mean, even with 10%, we are already doing something big. We can get even bigger there. The revised Renewable Energy Directive also introduces requirements for streamlined, simplified permitting processes covering the co-location of energy storage assets and the necessary grid connections. That's good news because this time thingy was always rather hampering. So we're really pushing that permitting is reduced not to years, but to months, and that important assets can come to the grid very fast. That was kind of a beneficial effect of the energy crisis, but I think it's stuck, and we will go further on simplification on that. We have also an energy system integration strategy, and our Commission Joint Research Center actually in that context estimates that the flexibility needs will double by 2030 and even be 7 times higher by 2050, again underlining the crucial role that integrated storage in the system needs to play. Finally, let me point out that we now also, that's also in my unit, actually, we came up with a Net Zero Industry Act. And in this, there are non-price criteria for renewable energy auctions that will actually push further for storage, because the system integration is also on the list of the potential non-price criteria. Thus, adding storage in the renewable installations is obviously one of the key ways to improve the system integration. And the implementing act for this started already for this article and will be adopted probably next year to come into effect. And these are just some of the angles. I mean, just 10 minutes, so not much more I can say there, but some other examples that we shouldn't forget. You talked about it this morning. Modernization and digitalization of the grids, very important. And then from my angle, again, I would also like to underline, and Battery Europe knows this well, but R&I funding through the Horizon Europe is substantial, especially through our cluster on energy, transport and climate. We're talking 15 billion in the 7 years of Horizon Europe. And to also reflect on what one of the earlier ones was saying on the hybridized storage system, I think it was in the first presentation, we already in the draft for 2025, the work where we have something on a digital twin, including the hybridized energy systems in the wider system. So I think we're very well aligned. I know you work more with Johan, but also the other parts of Horizon Europe under that cluster actually are very well aware, and my part on storage in the wider system is also looking into this, and obviously we're working very well together with you. And yeah, we can just conclude, you see, I mean, already with this small splinter of things that we are doing, the Commission is very much invested in the energy transition and fully recognizes the important role of RES and the combination with storage in this. I stuck exactly to 10 minutes. Over to you again.
Thank you very much, Jens. You have mentioned so many acts and there is so much happening in this sector. And it is very important that this is happening. And we see this policy is evolving with time. We're certainly seeing this trend. The real question is kind of when these changes are going to occur. Of course, we see vehicle to grid we can do this now. From a technical perspective, but when will it evolve that it will be a good business case? And also like the momentary reserve that Peter presented, when will it be a business case? It's a little bit of a question of how the sector is evolving. So I just want to say thank you very much, and I hope the position paper, and if we can do some future work to support you, because as the European Commission, you also need to get input from the stakeholders and some support. So we're certainly here and open and willing to help.
Thank you very much.
I will go to the next presentation for Pilar. I'm sorry to rush a little bit, but we're a little bit behind on time. But Pilar, you will talk about the maritime sector and give a little bit of a snapshot of there are other sectors apart from the storage sector, the stationary storage sector, that we can do a lot of work in. So if you can give a small picture of what you've done in the NEMO ship sector.
Okay, thank you very much, Edel. Yes, I'm Pilar, and yes, I'm working in CIDETEC energy storage, which is in San Sebastian in the north of Spain. So yeah, I don't know if you have the slides.
Yep.
Thank you very much. Yeah, so I will move to the maritime sector. In any case, in the position paper, there is also addressed the aviation sector, okay? But so if anyone is interested, can go through the position paper. But regarding the maritime sector, I would like to present NEMOSIP project, which is a Horizon European project, okay, and this is related to the exploitation of the energy storage systems and how to optimize the performance and how to integrate in fully hybrid and electric ships. This is an innovation action in which the leader is CEA, and the Europe funding has been nearly 8 million euros, though the project total cost is around 11 million euros. So yeah, next slide, please. So the main objectives of this European project is first to explore the flexible electrification solution to how the heterogeneous storage units, now we are in hybridization workshop, can help for the needs of the maritime sector. In this sense, we are exploring how to select the best arrangement between different technologies and chemistries for the different use cases. And also, we see that with hybridization, the aim is to decrease this capex when integrating the storage, in this case batteries, in the vessels, and how to address the different operational profiles. The second objective is to standardize the modular battery systems integrations, process, and interfaces. So the aim is to minimize this batteries installation time and also the risk of the incidents when installing. The third objective is related to digitalization, how to explore advanced tools for the ship's operators and owners to reach an optimal and safe exploitation of the batteries in the vessels. So how to provide more grid services and how to improve the operation of the batteries. And the fourth objective is to extend the zero emissions ability for both hybrid and full electric ships, because as you know, there is quite a lot of CO2 emissions in the maritime sectors. So with hybrid batteries and with an optimal sizing, we can also reach zero emissions. Next slide, please. Thank you. So regarding the innovative solution, the first one is to exploit these heterogeneous storage units in a modular and standardized way. So we have two demos. In one of them, there is one type of battery, which is a hybrid vessel with LNG. And the second demo, we are including a new 1 MWh modular and heterogeneous battery in this vessel. The second innovative solution is to develop a cloud-based digital platform in order to have online data-driven and how to optimize the operation of the batteries. And everything will be demonstrated in the vessels with a TRL around 7. Okay, next slide, please. So this project, we have a consortium with 11 partners from 6 different countries. There is 7 private large groups, 1 small medium enterprise, and 3 research technology centers. So we cover all the value chains from the research, innovation, and market. And yeah, we have a maritime battery system provider, also an integration, also a software provider for this cloud-based platform, a naval architect, and yes, and the end users. Okay, so we cover all the value chains. Next slide, please. So at the moment, we have done the first work package regarding the requirements and the experiences. And now, in parallel, we are working more in the development of the different activities, which is the digital platform, how to integrate these batteries in the vessel. We are also working in how to develop these algorithms for the better exploitation of the batteries. And yes, this will be demonstrated in the different vessels. Also, regarding the full electric vessels, there will be a semi-virtual demonstration with the cloud-based platform. Next slide, please. So now I would like to explain how, I mean, the lessons learned in this maritime sector when integrate and exploit these battery systems. Okay, in this paper, which has been published in the Journal of Energy Storage, there is a study in how we think we can go on in the further developments. And it's very important to increase the safety requirements for installing and operating the vessels which are containerized inside a vessel. So also it's important to standardize the interfaces. Okay, so this is a task for the ship owner and the system integration. Also, we learned that safety training programs is also very, very important and is needed for the crew to achieve this safe electrification in the ships. Also, the charging is very important, as we can increase these fuel saving benefits in the installation, I mean, from the installed vessels, from the installed batteries on the vessels. Another lesson learned is regarding that the future will be the offshore power supplies. So in this sense, we can reduce a lot of emissions. And I think this could be a future development. Okay, and regarding the required battery capacity on offshore ships, this can be also optimized. So, can enable the construction of more fully electric ships. So that could be also possible. And the challenging now, and this is the aim of our project, is to explore new optimal operation on for batteries regarding different multi-objective optimizations. Next slide, please. Another, let's say, work that we have performed is also not also to see which are the lessons learned in commercial vessels, but also in previous European projects. Okay, so what we have seen in the conclusions of the different European projects is that the modularity is a key feature for scale up from prototype to big systems. Okay. Also, we have seen that the energy storage systems can be hybridized in the sense of heterogeneous to avoid oversizings. So also being hybrid with, I mean, different technologies of storages can cover all the requirements. Also, it's very important to develop a control algorithms for these energy management systems. And also in future designs is in maritime sector is very important to take in consideration the weight and space constraints, okay, inside the vessels. So, well, in overall, what we want with the storage is to increase the genset efficiency in hybrid vessels with a combustion engine. And another thing of the heterogeneous energy storage is that they must be containerized to make easier the transportation considering the dimensions. Okay, so both technologies, if for example 2 kinds of batteries, can be in the same container. In these European projects, one of the conclusions is there is quite a lack of open access data. Okay, and there is not so much non-technical information like business models, business aspects. And also, let's say another conclusion is that in this maritime sector at the moment, second life batteries are not a viable option. Next slide, please. Yeah, so also in European projects, we have seen this heterogeneous storage for these different European projects, as you can see there, Ener, Nautilus, Seabat, etc. So most of them, the heterogeneous storage is a fuel cell plus battery. However, there are 2 projects which also there is a high power and high energy battery, the same as it is in Nemoship. Okay, and other ones they integrate flywheels with battery or supercapacitors with solid state batteries, as you can see in the list. Thanks. Next slide. And yeah, and now, well, also another technical tasks completed are related to the use cases definition and well, the 2 demos that we have in the project. The one in which will be retrofitted with 1 MWh modular heterogeneous battery. And the other one is Le Commandant Charcot, in which there is installed at the moment a 4.5 MWh of batteries, which is NMC batteries from Corvus Energy. Okay, next slide. And then, well, yeah, we have also done another requirements that you can check the public ones in our website, Nemosip website, and also you can follow us on LinkedIn. But before, yes, I will just say that, yeah, we have concluded with the sizing of the batteries, but we are just writing the deliverable. And also, yeah, we have a first prototype of the digital platform. And now it will, I mean, after it will come the installation planning of the battery, which will be next year. And also we will develop this for the full electric use case. So thanks for your attention.